The music is still going. At least I can still hear it. Hope it's not in my head. Good evening, everybody. Welcome to day 2 of the MPS Talk Series 2021. This is co-organized by JetBrains and the tennis. So, somebody, I can hear myself. Some feedback loop. I think, Tom, you might have speakers on.
Okay.
Very strange.
I've got headphones.
Okay. Yeah. Okay, I don't know what's going on. I can hear myself quite significantly about 5 minutes later. I'm going to ignore my other voice in my head and continue talking. All right, so welcome. My name is Markus Felter. I'm a language engineer who has been using MPS for around 10 years. This event is co-organized by JetBrains and Itemis. The JetBrains involvement is rather obvious, being MPS developers. Itemis has been using MPS for about 10 years, lots of customer projects, and so kind of share customers. So that's why we do this together, although the actual work of organizing has been done by JetBrains. And this is annoying to hear yourself 10 seconds later. The other thing I should mention before we get started today is that Eugen Schindler just sent me an email and he ported the MPS tutorial that I mentioned yesterday and to which I gave you a link to the new MPS. So now the comment that says it's outdated is no longer relevant. So thank you very much, Eugen. Today's talk, or talks, our second speaker is Federico Tomassetti. Some of you will know him because he is a frequent contributor to MPS stuff in general. He'll talk about building MPS-based ecosystems. And the first talk is by Tom Beadman. He works in the financial industry in the UK, in London, where else, I guess, if you work in finance in the UK. And he's going to give us an experience report about using MPS in that industry. You should thank him especially because yesterday was his birthday and he spent the birthday preparing the talk. So, Tom, thank you very much. And please go ahead.
Yeah, no, a pleasure to be here. Thank you. Thank you very much for having me. So yeah, thank you very much for that introduction. As Mark says, my name is Tom. I work for a company called IconSolutions, and we kind of work in the financial space. And we adopted MPS 1 year ago as a kind of like one of part of our toolkit. And so this presentation is really kind of to go over what the DSL kind of does for us, and kind of what's happened over the past year, really. Okay, so let me get started. So kind of for today's talk, I'm just going to do a couple of minutes kind of on background and about the context, 10 minutes about kind of the overview of the DSL. So it's obviously a DSL that we use internally, so it's not publicly available, but we can talk through kind of some of the concepts and that sort of thing and have a look at it. And then the main section is really this kind of hands-on demo. So I'd like to kind of start from scratch with from a clean slate, but with a template project, build an application using MPS and run it up inside a container and kind of see what's going on. And then finally, kind of 10 minutes to talk about kind of milestones and our observations over the past year of using MPS. And we are coming from it from the perspective of kind of, people who are very new to it. We're not language engineers. We're just kind of standard Java engineers who've picked this up and seen how powerful it is. So we kind of run into lots of the same challenges and overcome those kind of hurdles that I think a lot of people will as well. So that'd be quite useful. And then obviously these kind of 50 minutes towards the end for any kind of questions and answers. So with that, I think I'll get started. So just about a bit of background. So we're talking about kind of payments really at the moment. So if we think about making a payment, say if I want to pay Marcus and we're in different banks, what does that actually mean behind the scenes? So there are a kind of couple of key concepts that we can need to really define before we can identify where a DSL fits. So everyone knows what a bank is. So that's fine. It's a place that you hold an account. And then you can have different types of payments. So you know yourself that some payments can be quite instant. They can take a few seconds. Other payments may take several days. And so there's kind of different sorts of payments that can go to be processed. Now, in order for one bank to pay another bank, the payment needs to be kind of transferred over what's kind of known as a scheme. And this is kind of like a high level kind of specification, really, that defines the financial message exchange formats. And so you've kind of got operations in there, such as, sending a payment, querying the status of a payment, cancelling one, or returning one. But that's at kind of like a really kind of broad, high level. So there'd be like European schemes. There's the concept of a clearing and settlement mechanism, which are sometimes called a CSM, and those typically implement a scheme. So they'll implement kind of the specification and provide that functionality to a certain geography over a central infrastructure. And so typically you have lots of these different CSMs which implement different schemes, and a bank will be able to pay other banks by going through these CSMs over these schemes and kind of building out that network. So the reach of a bank to be able to pay from bank A to bank B, which is in a different country, can be kind of seen as going through like a web of connections between CSMs to maybe other indirect banks and that sort of thing. So banks have an interest in obviously in building that kind of communication and connecting to these CSMs, and they may choose to kind of build everything in-house or buy off-the-shelf products in the form of payment service providers or a PSP. So a PSP may typically provide that kind of CSM connectivity, as well as some kind of more orchestration-focused capabilities as well. So a bank may leverage those kind of PSPs to be able to connect out to a scheme. So those are a couple of some of the basic kind of concepts. And if we look about, okay, well, where does kind of MPS fit in here? So the company I work for, IconSolutions, we are specialists in providing payment solutions and enterprise consulting for financial institutions. Of that point, we have a product called IPF, the Icon Payments Framework, and that is kind of like a platform or an open product that provides those kind of PSP capabilities. So scheme connectivity, payment orchestration, and that sort of thing. And its key focus really is orchestration of the payment processing and also integration and integrating to bank systems. So MPS was kind of recently adopted as one of the approaches that we were going to use for our domain modeling, specifically for the orchestration aspect. And what we wanted to get out of that was kind of, extensibility, but also simplifying the engineering process. So that's kind of where MPS fits in the context of these things. So this diagram here is kind of just a very, very crude view of if there's a person in the top left, they would like to pay someone from another bank. What that ultimately looks like is the bank connecting out to the scheme, either directly or through a PSP, in the form of a submit payment. But prior to that, there are lots of different things that the bank may or may not want to do with that payment. There are certain things that are always typically invoked, such as fraud, sanctions, and accounting. Those will be different systems for different banks, but the entire processing flow itself may also have a completely different shape. So there's kind of a kind of processing orchestration type flow prior to submission to the scheme, and that's where IPF currently fits. And then if we look at this from the beneficiary bank, so the other side, the bank who are receiving the payment, there's kind of like as you'd expect, a mirror image. So the originating bank who sent the payment through has gone via the scheme, is now being received by the beneficiary bank, and they may too require some kind of processing flow that they want to be able to build into that payment. And so when we kind of look at the different processing flows that can happen, we kind of see that it's a really good candidate for explicit modeling rather than just building in a traditional application. So the next question is kind of given that, well, why a DSL and why MPS? And why do we kind of choose to go with this? And so the IPF product has been around for a while. We're constantly innovating, and as part of our kind of previous innovation round, we kind of looked to a more extensible kind of software architecture. So adopting event-driven focuses, event sourcing, and to kind of be more microservice orientated as well. And that provided us with a kind of a good a good platform or a good opportunity to also review our domain modeling approach. So we had a previous approach in terms of domain modeling, but it was using kind of an external tool. It was kind of one of those visual modeling tools where business analysts could define a processing flow, and there we would then take that model and then generate code off the back of it. But that was from a separate application, and it was quite heavyweight. And the code generation was also kind of not really coupled to the internal model. You were always generating from a foreign model effectively. And so because of that, the code that was generated was quite anemic. It wasn't really that valuable. It was kind of boilerplate stuff, really. And also there was lots of bleeding between business and technical concerns because there was no real kind of concept of what the business flow was. There were technical concerns which were creeping in there. And the outcome from that is that the engineers who build software on top of the generated collateral from there are often fighting kind of against the grain because the intention has kind of been lost. So we needed a kind of an alternative to look to, a nice kind of lightweight alternative. And I guess some of the characteristics of the alternative that we were looking for, we wanted full control over the model. We wanted to be able to define the kind of concepts that were meaningful to us, as well as the kind of process from the editing through to generating and that sort of thing. Because by having kind of more control of the entire process, we were going to end up with higher quality generated code. We also kind of wanted better integration with our existing developer tools and workflow. So we wanted that to be kind of smoother and potentially transparent as well. We kind of wanted that high quality generated code and for it to be self-contained as well. We didn't just want to create kind of anemic functions. We wanted to be able to build a kind of generate a domain which was a true representation of the model. And the desire for the model itself to be liberated from the application and decoupled from the runtime technology. So that's kind of what we were looking for. And, you know, MPS kind of really fit the bill on that from our kind of experience. So, yeah, the next section really is to kind of look at the kind of concepts that we came up with and the concepts of the DSL. So before, I guess, kind of looking at the exact concepts, these are what we wanted the DSL to be able to generate for us and what it currently does. So we're kind of going backwards a bit, but the first and kind of the most prominent is the ability to generate a self-contained Java domain. So what we're generating is an event-sourced Java domain powered by Akka, by Lightbend, and it's modeled as an event-driven finite state machine. So, you know, finite state machines should be kind of no stranger to DSLs. That's kind of where we're going. And that's achieved by a generator, a baseline generator. In addition to the main domain, we also want to generate lots of kind of auxiliary collateral, such as test-focused collateral. So in addition to generating kind of, you know, Java classes that are suitable for testing, we're also generating BDD scripts. So we're a big proponent of behavior-driven development as an organization. And so by having the processing flow modeled in MPS, it allows us quite easily to be able to traverse it, the different processing paths, and define a BDD testing scenario for each one of the paths that could potentially happen during that processing flow. And then these BDD scripts are then further, you know, leveraged by our testing harness further down the line. And then in addition to that, we generate documentation in the form of ASCII doc to help expose some of the concepts in the DSL, which feeds into a documentation pipeline, and also the visual collateral as well. So we knew that we were moving from a kind of visual first, visual model to code process to something which was more traditional by defining with a DSL, but we still wanted that kind of visual element as well. And so we generate graph representations as dot, and they get published as well. So that's kind of where we're aiming for and what we've ended up with, which I'll be able to show as part of the demo. Okay, so primary kind of language concepts. So these are just a kind of list of the most important kind of concepts that we built the DSL around. And this should be quite familiar to anyone who's kind of, you know, built state machines and that sort of thing, or worked in kind of like a DDD process. But first of all, we define data. So we have data as a concept, and that has kind of IDs and also a link to the associated Java type, which allows us to, effectively generate kind of the correct Java types as part of generation. So we couldn't do without that, and that's where MPS proved really good, the interop with Java. We've got events, so those would be domain events that the business analyst would define as part of the DSL, but also kind of internal events as well. The scope of the DSL for a model is to be able to define a kind of a finite state machine which represents the processing for a domain or a single domain. Now, most non-trivial domains always need to interact with other domains really to get information or to be able to kind of evoke kind of elsewhere so that you can finally progress. You don't really kind of get lots of standalone things. So we have the concept of the external domain as a concept. And then we have the concepts of inputs and actions. So really these are instructions or commands being received into the domain or responses, or instructions, commands, and requests being sent out. So those represent the inputs and the outputs to the domain itself. There's also the concept of kind of like a decision. So being able to perform a decision in multiple places as part of the state machine definition. And then finally, the behavior. And the behavior really is that kind of state machine representation. It's the domain itself, and it's built on top of all these other, and it uses all these other concepts. And as I said, there are kind of numerous other kind of supplementary concepts as well, but those are really the key ones. Now, if we have a look at kind of how those map through to the generated domain, it should not really be that kind of surprising that you define an event in the DSL, you get an event POJO generated off the back as well. But you also get all the other collateral which is needed. So the finite state machine takes the form of an ACCA event sourced behavior. The inputs come through to commands, and then depending on the domain and how things are configured, there are obviously command handlers, command processors, event handlers. There's the idea of kind of the aggregate, which is the summation of all of the data and all of the states. And we need to generate lots of other kind of common platform classes. And those inputs and those actions that represented the input and output, those get generated into input and action ports. So in I guess, ports and adapters architecture, those are kind of like interfaces into the domain that the application can hook in. And interfaces out that the application will then support. So let's keep going. Generated domain. Right.
Tom, before you do the demo,
Sure.
Just briefly, I forgot to mention this before. If you guys have questions, please type them into the chat in YouTube, and I will collect them and ask them later. So far, we have no questions, so I thought I'd emphasize that's the way we should do it.
Okay.
All right, dropping out again.
No, that's great. Thank you. Cheers. Okay, so that's kind of the outlook. So let's have a look at the demo. But before jumping into that, just a couple of notes on what we're building as part of the demo. So I'm going to start from scratch, but rather than cloning a kind of example project and changing a bunch of stuff and then kind of testing it, we're going to leverage just a quick tool built with Yeoman. So this is going to allow me to kind of build a sample project with a example MPS solution using the language, but parameterized as we build it up. And it's generating really a multi-module Maven project where the MPS module is kind of one small component of that, and that's represented in the domain. And then what we build out from that is we're gonna generate the MPS solution. It's gonna build a domain which is built on top of ACCA. There's also a kind of really thin application layer, Spring Boot application, that effectively wraps the generated domain, and it exposes the commands out on a REST API, and then finally bundle that into a container and run it up, all as kind of part of the same process. So that's kind of where we're aiming. So let me move over to the terminal. Okay, so that should be showing okay, friend. Let me know if it's not clear. Right, so we've kind of got a blank directory. So now I'm going to invoke the generator. And then this is basically just going to ask me a couple of questions, and it's just going to name the project, set some kind of packages and that sort of thing, and add the templates. So let's do pasta. Why not? Let's just do, base package conf food. Great. And then on there it said what model template should be used, and it said example fraud. So it's created us a bunch of files. If I have a look at what those actual files are, we can have a look at the MPS solution. So we can see that it's generated a top-level project, and it's got those kind of 3 modules which we looked at on the slide. So a domain module, an app module, and then a kind of container module. Within the domain root, one of those submodules is an MPS project, and it's built a solution called Pasta, but it's using the example fraud template, and it's got these there. So whilst I'm looking at this, I'm just going to set the build off to compile it, because that takes a second. Bear with me one sec. So anyone kind of familiar with Maven, this is just doing a Maven clean install, skipping the tests, and it's also passing a parameter just to build a container. So instead of looking at the build script for Maven, let's just have a quick talk about what's going through on here. So when the build goes through, it first of all compiles the MPS module. And what that does is it goes away and it downloads a version of MPS from, I think it's the Itemis Maven repository, pulls it down, and it compiles the Pasta solution using the build script against that version of MPS with all the kind of plugins configured and everything. And at that point, all of the generated collateral is kind of in the target directory of MPS. We've then got these kind of sibling modules, the docs and the domain and the test, and their Maven process is basically to go into the MPS directory that's been generated and to extract all the collateral that they care about. So the domain will get all of the domain classes, the docs will get all the documentation, and the test will get all the test classes. And at that point, none of the downstream project really kind of cares about the MPS module at that anymore. The application only really cares about the domain, and so it imports that as part of the build for the application. It builds a container, and at that point we can run it up. So I'm now just going to open up MPS so we can have a look at that solution. 1 second. Using the handy JetBrains toolbox. Okay, so whilst that's starting, I'm just going to start the containers as well. Okay, so let's have a look in here. There's the H. Why is it not showing it? 1 second. Oh, there we go. So we have our kind of Pasta project. We've got the kind of 3 modules in there. As part of the domain, we have the MPS project. Let me open that up. Just ignore these warnings. Great. Okay, so it's kind of very, very simple. It's kind of just created the solution, which has been parameterized with the values we put in as part of the generator. And it contains some usages of the DSL. So first of all, let's have a look at the data library, what we call business data. So we can see here that we're kind of just defining different data points that are being used for this example. If I enable a technical view, we can also see that we've got the data type there. So this is kind of our how we handle kind of representing different types to generate to on the domain side. So we care about the sender name, the recipient name, and the amount. Obviously, auto-completing on there, that's picking up one of the Java types. Once we've defined the data, we then want to associate that with the domain. So this is how we define kind of the state machine. And we recently added, which I'll throw on here, the graphical view, which kind of gets launched by an intention. And so we kind of said that the graphical view really was something that we were generating off the back. But very recently we decided, well, we don't actually need to generate it. We can load it up as part of the editor as well. And so for those interested, you can know it's kind of like it's listening via, I guess you call it node listeners. If I change validating there, we can see all that. If anyone's kind of got any interest on this, give me a shout afterwards, because it goes through quite so many hoops to get this. But this is a flow that we're kind of modeling. So we receive a payment and it goes into a validating stage. Upon the validation response, we make a decision as to whether or not we need to check fraud. If we don't need to check fraud, we just go straight through to successfully processed. If we do need to check fraud, then we go to checking fraud, and then based on the fraud outcome, either it's rejected or successfully processed. So that's kind of the flow we're looking at. And you can see here that we've got the payment request received event, which is associated with those data elements. And so by doing that, you kind of build up what data is required. And ultimately that kind of gets propagated through. So if we have a look at the decision for well, I'll tell you what, let's have a quick look. So the decision as to whether or not it requires a fraud check is the concept of decision that we've got here. I'll get rid of that. So we've modeled kind of a decision by leveraging the lightweight DSL, and this is a relatively new addition as well. Previously, we used to kind of define application decisions, associate them with data that they operated on, and basically what that would just generate into an interface that the application would then need to implement. But then we thought, well, rather than leaving the application to do it, why can we not make the domain be a bit more autonomous and kind of have those decisions there as well? But we didn't want to reinvent the wheel. So lightweight DSL proves to be quite useful to be able to kind of define this function, which would then be used in the appropriate place. So that's kind of like a look at the DSL. Now, let's just quickly, what I'd like to do is we can go in, test it, then come back, make a change in the DSL, redeploy, and kind of see what happens. So let's have a look. So Docker Compose has started. If I go onto here, there should be localhost. So this is just a kind of really simple web page that we put to save having to do kind of curl requests to be able to kind of trigger this processing flow. So let's say Tom sends Pat 50. Initiate the payment. And we can see that it got successfully processed and the previous state was validating, which is great. If I send Pat 150, we can see that it went to successfully processed, but it also bypassed. It also went through the checking fraud stage, and throw out. Sorry, checking fraud. On the kind of fraud bit here, we have kind of a magic value to say that if the recipient is max, then we should reject that as well. Sorry, let's send him 150. Must be a bit suspicious. Then we go through and we can say, right, okay, so it was checking fraud and it was rejected at that point. So that's just kind of proving that it's kind of generated. If we now look at kind of making a change, and what does that look like? Let's do that kind of on here. So let's add a new business data point. Let's say that we add a new field. Let's call it false fraud. let's make it a Boolean. So we're gonna have a flag that the initiating request can set, so that we always go to fraud regardless of the amount of the payment. So that the payment was only going to go to fraud if it was greater than 100. So on here we can go in and say, right, this decision is also dependent on false fraud. We're going to say that, okay, we want this to return true if the amount is greater than 100, or false fraud. Now I can generate this in the IDE, and that'll be perfectly fine, but I want it to be absorbed into the application and redeployed. So it's quicker for me just to do the Maven install. Whilst that's building, so just to kind of, whilst that's building, just to kind of recap what we've done. So, well, that's probably not. I've destroyed everything by doing a Maven clean install, so I won't go into MPS whilst it's doing that. But essentially, we've added a new data kind of point. We've associated it with the event that is triggered by the initiation of the payment, which means that it's required on the command. And we're rebuilding everything, and the command is currently being exposed as a REST API. So I should be able to now go back into the application. What's happened on here? That does not look healthy. Okay. I think I kind of maybe messed something up. So in the interest of time, I might kind of skip over this point. Let me just try and regenerate it from here. Okay, let's leave that. A couple of teething issues, but that's fine. Okay, so let's kind of maybe move on to the, I guess, are there any kind of questions on the demo before kind of moving on to the next section, which is talking about the different milestones and what we've built?
So yes, indeed, there was one question.
Okay.
How do you keep templates in line with the MPS model? I don't know what templates they're referring to.
Yeah, it's an interesting question. We kind of need to find a proper, currently it's a manual process. So we would be up-versioning the template effectively, or up-versioning kind of an example, going through, seeing what the actual changes are, and kind of then backporting them into the template. I'm sure there's a kind of nicer way, but the templating aspect for us is kind of just a kind of quality of life thing. It's not a crucial point of the process, but yeah, currently we're, I guess, retrofitting the changes.
This templating refers to the stuff that's generated by Yeoman. That's the templates you're referring to here.
Yeah.
Okay, all right.
Yeah, exactly. Yeah.
Okay.
Yeah.
Any other question at this point? Doesn't look like it. If I ask now, of course, it takes 10 seconds until it propagates down to YouTube. So I suggest you continue.
Yeah, no, that's great. That's Karen. Okay. So yeah, and we kind of obviously generate kind of other collateral such as the BDD scenarios and that sort of thing, which we find very useful as well. So the kind of the next section would be, I guess, just kind of talking about our experiences building this kind of over the past year. So there's been kind of a team or between kind of like 1 and 3 at times, kind of working on this on and off. So kind of broken it down to different quarters. So the kind of the main milestone that we kind of had during the first quarter was the initial proof of concept and kind of getting to grips with MPS and kind of seeing why it's valuable. And for me personally, it was the interoperability with the Java types from the language itself, but also when building a generator and that sort of thing, that seemed very, very like powerful. And the ability to kind of generate multiple outputs. I'm not sure if it's kind of like a purist way of putting it, but the fact that we're able to kind of generate documentation as well as test scenarios, as well as application code and that sort of thing from a single model was extremely powerful. And it's you're kind of in the best place to be able to do that within MPS, and kind of appreciating the projectional editor. So like even now, kind of a year on, I'm always kind of like running into issues or what I perceive as issues. I'm sure other people do as well. But it's once you understand what it's actually doing, it's kind of so powerful, and it often just kind of needs that extra bit of guidance from maybe someone else who's worked with it, or maybe like the Slack channel and things like that. But it's extremely powerful. And then the second point was, how do we get this as part of our kind of application, and kind of like building from the command line, really. So how do we use MPS as part of our toolkit for modeling our domain, but also kind of keep it simple and transparent to kind of downstream developers effectively. So the ability to download MPS, a headless version of MPS, and use it as part of a Maven build process was a key kind of hurdle that we got over, thanks to lots of other people's help. And then all of the things that are required to be able to do that, such as defining build solutions, being able to kind of do the plugin management and dependency management. So shout out to Federico for, I think it was one of his blog articles about how to sort out your kind of dependencies was really helpful on that and getting us started. So that's good. And then kind of looking to the kind of the second quarter, really, then we looked at, right, well, okay, fine. How do we start using the language in our downstream projects? Obviously, this is kind of like private and internal, so it's not publicly available. So we have to build the plugin as currently as a zip, and then we publish that to our internal nexus. And therefore it can be used and imported with Maven as kind of any other kind of build artifact. And then we started looking at, well, what does the downstream project need to look like in order to be able to build it this way? And so we kind of looked at this, because if you imagine this, there's so much kind of complexity. If there's so much kind of complexity in terms of setting up that build structure to be able to have it transparent and effective, and what was the best way of doing that. And we kind of looked at we leveraged Maven's kind of concept of the differences between a parent POM, parent module, and an aggregator POM. And so a project in Maven, a POM, can have a parent, and therefore the child will inherit not only kind of the dependencies as you would expect, but also all the plugin configuration. And so we were able to kind of encapsulate all of that heavyweight MPS processing build configuration in a parent POM, and therefore the downstream project just needs to have a kind of POM which inherits from there, and it doesn't need to have any content effectively. I think it needs to specify what the solution name may be, but it's by leveraging those starter modules there, and those starter modules live in the repository of the language itself. So if you change the language or kind of the process at the kind of language level, you can change the starter modules, and then all the other projects downstream, they just need to up version their parent version effectively. So taking a new version of the language becomes kind of synonymous almost with upgrading a Maven property version, which is very powerful. And then we kind of go further with that and say, well, okay, how do we guarantee that the downstream project structure is going to be consistent, and that's kind of where we look into kind of like Yeoman and templating and that sort of thing as well. But there are also different approaches. Off the back of that, we then introduced the kind of integration test module. So this was going to be an example downstream project structure project that was part of the main language lifecycle, and its job was to consume the language distribution zip, import it into its solution, and for it to build. And so it was really testing that the language had successfully built a coherent distribution zip. And so that was very, very important as well. So we couldn't release a version of the language if it was going to effectively break downstream projects, which is never desirable. We then kind of, obviously we're getting feedback through this entire process, but we had a kind of key feedback point in Q2 where we're able to present this DSL not only to kind of like our internal developers, but also to clients who would be kind of using our software and were interested about what our engineering process was. And the kind of the feedback is generally extremely positive, and especially if you kind of get those kind of clients who are technical as well, and especially if they've been exposed to previous DSLs, they immediately get it, and that was really great. But they did raise kind of interesting questions for us to kind of consider about what we wanted our DSL to do regarding extensibility and kind of reusability of language, like the DSL components, which we'll have a look at in a second. During kind of quarter 3, we kind of stress tested the DSL by modeling different use cases. So, you can imagine a single microservice with multiple different domains working together. What should that separation be? Should it be represented at the language level or the application level? And that sort of thing. And off the back of trying these different use cases, we got lots of new language enhancements, language requests to be more generic, and we kind of also refined kind of the scope of the language and what it should be. And then we also had at that point kind of support from JetBrains as well. So thanks to Vaclav and Artem, who worked with us to kind of go through a checklist about things that we were doing maybe correctly, things that we could improve on, and that sort of thing. And it probably surprises no one. A lot of kind of the improvements that we could make were based around kind of our generator. It was a bit monolithic. With their help, we managed to kind of split it down and make it more modular and more kind of reusable and all that sort of stuff. At this point, again, we kind of then looked at, well, how do we handle the reusability? So the question was from the client is, well, so if I can define my domain in your DSL and I can define my external domains in your DSL, how can I reuse those external domains in a different domain that you're also building for me effectively? And so we kind of pondered that, and the initial view was to look into kind of cross-model generation, and to effectively kind of allow partial DSLs to be made and then to be reused in existing models and that sort of thing. The more we kind of explored it, we kind of put a lot of time into it, we kind of realized that for our use case, it was becoming like overly complex. So one of the IconSolutions kind of tenets really is to kind of simplify complexity when you see it. So we kind of took a step back and was like, there's something that tells us this probably isn't the correct way of going about solving the problem. So we kind of instead kind of took it back and thought that we can provide reusability at kind of the application level, but as far as the DSL, that's kind of self-contained within the domain. It's okay to have kind of redundancy and repetition between domains. And so from that, we kind of thought, well, we'll continue just with like the templating approach, but also looking into kind of the new persisting your model on a DB kind of features. I think there's a talk coming up about, but we kind of think that might be our preferred option to go with. And then kind of finally, I think this is almost like the last slide before questions really, it's the kind of the most recent improvements that we've done. So we did some kind of technical quality of life improvements. So we were running into issues where we had a duplicate kind of mapping label, multiple reference macros being identified for a certain mapping on kind of duplication. If we imagine that we've got the idea of a data point, and we know that we've kind of got the idea of an aggregate, which is going to have a list of all the data points which are used as part of the domain. But we also know that the inputs and the commands, they supply those data points. But different commands may supply kind of the same data point effectively. So in terms of generating through onto the aggregate, you can't just take all of the data in the DSL because it may not be used. But there's no direct link from the state machine to all of the data points it uses. You need to go to each of the commands it receives and get the data from there. So there's a degree of separation. And because of that degree of separation, there's also the issue of duplication. So we really needed to be generating from a relationship that existed, but didn't exist in the DSL. And the relationship was that, this state machine uses these unique data points. And so we built that and we leverage the kind of the preprocessor generation step to be able to programmatically build that kind of separate concept, like a contextual read-only kind of concept. And the generator can then leverage that to be able to map from those nodes, as opposed to trying to map from something else. So that was quite an important thing for us. Also leveraging the lightweight DSL constructs, kind of seen that. And also the Yeoman project instantiation, which is kind of like an extra bonus that we've got on there. So that was kind of on the technical side. On the user side as well, we did a rich client distribution option. So thanks, Pat. My colleagues made that, so that was great. So that allows kind of, it's a self-contained IDE, slightly kind of customized with our language. And so business analysts can use that to be able to kind of sketch up different flows. And then developers may just elect to use normal MPS with the DSL in the scope of a wider ecosystem. And then we got to the point of the kind of graph visualization. So previously we were generating this. We were generating using text gen through to dot, and then converting that to an SVG as part of a Maven step. But now we've kind of front loaded all of that into an intention within the editor. So I think, and someone's going to correct me probably, is that class as an interpreter? I'm not quite sure, but we'll find out. And then finally, kind of obviously better type checking rules and constraints. And so kind of the general stuff needed to be able to ensure that the domain is kind of consistent. So that's it for my slides. So before kind of, I guess I'd say thanks to Marcus and JetBrains and Oscar for hosting and everything. I'm sure if there's any questions, that'd be great. But if not, you can follow me on Twitter, although I don't really post that much. And obviously we're hiring. So if any of this looks interesting to anyone from language engineering or Java engineering or payments, why not? Feel free to get in touch. Thanks.
All right, Tom, thank you very much. I found it very interesting. We have a couple of, well, first I have a comment. I thought one thing your talk very nicely illustrated is that in addition to building a useful and usable language, this whole infrastructure around it, the automation through Yeoman and the build, is really important. You called it quality of life for users. I thought that was a nice term. And it's something that some people, including myself, tend to not emphasize so much, and instead just build a cool language. I thought you put it into context very nicely.
Thanks.
Yeah. Any comments there, or should we continue with the questions?
No. I think yeah, that's true. There's I'm kind of personally always looking for building things which developers are going to enjoy, and obviously business people as well. But it's always that extra kind of I guess shine, or the extra kind of user interface that makes things slightly nicer to work with. MPS is extremely powerful, but there's a high barrier to entry to be able to adopt it without that kind of supporting process. And getting there, sometimes it is painful, but there's experts and there's the Slack channel, and there's lots of people willing to help. So thank you for helping us get there.
Yeah. Philip is asking in that same context, he's wondering why that Yeoman generator was built in the first place. Do you create new model projects so frequently?
Potentially, yeah. So a lot of our projects are longer lived and they will kind of start from scratch. But there's been times even this year where I've needed to kind of, we're doing a proof of concept for a client, and I need maybe kind of, 5 or 6 different microservices, each with a slightly different kind of domain. And we need to be able to kind of prototype and build that out. So the Yeoman generator is just a kind of an extra tool that we have at our disposal to be able to start something kind of up from scratch quickly, and to get that kind of that place there. But no, production projects, they're a bit longer lived, but we have to adapt.
Yeah, so you built it mostly to improve your own life.
I built it because I thought I started using JHipster and thought, wow, this is amazing. So out of interest, I kind of looked into how that was built, and then how we could template it with MPS as well, and thought that this is quite cool. So I kind of kept it maintained, but yeah, it's could call it, what is it, like if you're buying a car, is it an optional extra or something like that? It's one of the comforts.
Right. So Julian asks, what tools, languages, IDEs were you using before MPS has replaced those? What was the previous tool set?
Sure. Yeah, sure. So MPS hasn't really replaced it, but the previous tool we were using was a Modelio. So I'm not sure if kind of people are aware of it, but it's kind of like an enterprise model to enterprise diagram to kind of model solution. And off the back of that, it ends up with a kind of XMI format. And our generation was translating that XMI with Python into Java code, which worked. But it worked when we had a kind of narrow focus that our product was going to be specifically focused on instant payments. And now we're kind of changing to be able to support different payment types. We needed a more flexible architecture. So once we moved to be kind of event driven, that was a good opportunity to say, right, can we just use a DSL here rather than have this dependency on such a big external product?
Yeah, I was going to ask you. You used the word heavyweight and lightweight, and I was wondering what that heavyweight solution was. But now you mentioned a tool whose name starts with enterprise, and that explains it, right? So
Sure.
Usually these are heavyweight. Paul says, yesterday Marcus implied that making a graphical projection was more effort than value. You used the visualization instead, one that updates in real time, which is actually quite nice, my comment. What was your experience with that? Is that a good compromise?
Yeah, I think so. So that's kind of, so we always knew that we were going to need a graphical representation in order to be able to get anybody on board with using this DSL kind of really, because as nice as kind of the state machine is, it's very difficult to be able to kind of see exactly kind of what's going on. So we always knew that we're going to need to translate to graphs. And that's just kind of done using, JGraph-T or something like that. The process of then front loading from the generation through into the intention in MPS was quite interesting, but very, very much doable. It was, it's basically injecting kind of the swing components into the editor and that sort of thing. What I found is a lot of these sample projects that come with MPS contain exactly what you need to know to be able to solve these problems. So in order to be able to have that diagram that pops up, that's in the shapes example. In order to be able to use lightweight DSL, it's in the lightweight DSL example and that sort of thing. So if there are kind of a message for anyone wanting to get started, aside from everything else everyone else has said, it would be to consult those.
Yeah, that's one of the nice things, because everything is kind of defined in MPS. You can always do a Control-Shift-S and inspect everything, and so it's not necessarily always easy to understand conceptually, but technically everything is explorable, which is nice. Yeah. How big is the audience using the solution, and how technically advanced are these people so they don't struggle with the complexity of a desktop IDE? And I think Mike was asking that.
It's a good question. So this is still kind of relatively recently adopted. So our IPF product, it's live with production kind of customers over the kind of the past 5 years, and this is a new addition. So we have a live project. We have a project which is currently being built, which is using it. We don't have anyone yet who's currently using this in a kind of live system, but we kind of work with our business analysts together with them, kind of using the solution, and we're currently going on that journey to see, okay, how do we make things better for the end user and that sort of thing. But we're learning. We're not language engineers yet, but I think it's kind of, hopefully it's good progress for you.
One experience many of us had is that it's relatively feasible and maybe even easy to build a language that is accessible to non-programmers, to domain experts, if the language fits well with the domain. But if you then give them this huge tool with 5 million buttons and Git integration, and it just overwhelms people. And one way to simplify that is to deploy an, as we call it, RCP term developed from the Eclipse world. You remove all the menus and buttons that you really don't need. But this simplification and integration into people's workflow is a major driver for both Themis's and JetBrains' efforts of bringing all of this to the web. And we'll have talks about that later this week. But that's kind of where this comes from, right? To make the Chrome around it simpler, not just the language itself.
Yeah, and yeah, definitely, and that's definitely one of the things we're going to be kind of we're very eager to kind of look at, and I think a lot of people are as well. Is kind of the web side of it, and also as kind of mentioned that database persistence of models and that sort of thing, where we can have kind of repositories. Very 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 interesting for us.
Yeah. Nolly is asking that MPS UI with sections. What was that using the default MPS editor or with the help of Embedder?
I'm not sure what they're referring to, but this is pure
Me
MPS.
neither.
I can say that.
Okay, it's pure MPS. All right.
Yeah, it's pure MPS. So we haven't kind of used any of the special embedder add-ons or anything like that. So table editor, MPS, I think that's pretty much it.
Okay. So that's a question from me. You explained that you're generating BDD style tests, or at least test skeletons.
Yes.
Which means that you have to generate all the stuff, deploy all of it, run Docker, and then you, I guess, write BDD tests against the full system. Have you ever thought about also allowing your modelers, while they're in the IDE, to write tests against the model and not only against the fully generated and deployed solution afterwards? And if so, would that also be BDD, or would that be a kind of testing language that you would develop as well?
Yeah, I think it's a good question. It's a shame that that last compile didn't go through. Let me just check if that was on there. But the BDD it currently generates, it will inspect the model and it will write a BDD scenario saying that, one that results in the kind of fraud rejection, and two that result in the success for the different permutations going through. But really, that's just from the model side. And you could say that, well, you're generating the domain from a model, you're generating the test case from the model. Is this not kind of a cyclical? What's the value of the test? Which is a fair argument, but the counter really is that the main purposes of those BDDs is to be able to illustrate the different scenarios through the processing path, so that when you build an application around the domain, you have a reference point to be able to kind of say, okay, does my application cover these scenarios and that sort of thing. So that's it's complementary to normal testing.
Exactly. So another way I like to say this is these kinds of generated tests, their purpose is to exercise the whole system and go through every kind of corner.
Yes.
It doesn't mean that every, let's say, business-driven corner case is covered, right? It's complementary, just exactly as you say. Yeah.
Yeah, you can only test what's in the model and what's being modeled effectively.
Yeah.
So yeah, it's completely complementary, which is.
But I would still think it would be nice if people could write tests against the state machine without all the generation backend stuff, just more test-driven development of that thing. Could be an interesting avenue to explore in the future.
Yeah, definitely. Yeah, I think we're definitely kind of looking more into kind of the testing side, from testing the generated collateral, but then also node tests on the individual kind of parts of the language and editor tests. We're kind of building that knowledge and capability up as we're going through.
Right. All right. I have no more questions. Let's wait 10 seconds until this statement pops through to YouTube, and maybe somebody adds a last question there. Now I guess we have 8 seconds, 9, 10. No more questions. Then Tom, thank you very much. I thought it was a very interesting presentation. Thank you very much.
No, pleasure. Thanks for having me, and thanks for everyone's attention. Cool. Have a good session.
Yeah, thanks. All right. So our next presentation. By the way, I figured out why I had my voice in my head. I was also running YouTube and I didn't mute it. Too many buttons for me. So our next presentation is by Federico. Federico, are you there?
Yes, I'm here. Hi, everybody.
Hey, hello. People probably know Federico. He is one of the, it's funny, in your last Thursday. So Federico runs these language engineering meetings every Thursday evening. And some of you probably are here because of that other meeting. And in the last meeting, Federico gave a talk and I introduced him. So I'm going to do that again. So this is Federico. Perfect. He runs Strumenta, an Italian language engineering community company. He also runs the community around it. And again, yes, is there anyone who doesn't know Federico? Yes, maybe there are. So today he's going to talk about making MPS part of an ecosystem, getting stuff in, getting stuff out. Again, it emphasizes this thing that I also mentioned in Tom's talk, that I like how he used Yeoman to kind of bootstrap a project, and emphasizing that there's more to a project than just language. And I think you're kind of going in the same direction, Federico.
Yes, yes.
All right, then take it away.
Okay. Well, thank you. Thank you to JetBrains and Itemis for organizing that. And it's quite an honor to be introduced by Marcus. It's going to be difficult to follow the previous presentation because this was really great. Mine is going to be a bit different because I'm not going to show you code running into MPS, but I'm going to talk about some of the potential usage that you can do of MPS, and hopefully this will give you some idea to get more value out of MPS. Now, for the last few months, I've been reflecting around this idea that most of the organization we work with have at their center something that they use to produce value that affect their processes, it affects the internal communication, it affects the R&D efforts, it affects training. And that is, of course, knowledge. So for many of the organizations we work with, knowledge is the main way that they use to produce value. So because this has to be taken in account in the process they develop to create knowledge in the best way possible and to take to produce value out of the knowledge they build. Communication is mostly about communicating the internal knowledge that is built. R&D development means often creating new knowledge, but also putting knowledge to use. And in my opinion, this is where I've seen many organizations running into issue because it takes too much time to transform the knowledge they have into a product that is valuable. And finally, training is also about spreading this knowledge to all the new people that join the organization during the life of the organization. Okay, this is a bit abstract, of course. So let's try to understand why this is related to MPS. Well, I think this is related to MPS because basically we use MPS to capture knowledge and store it into MPS models. Then when this knowledge is captured into models, we refine over it, we improve it, it evolves over time. But this knowledge remains trapped into MPS, and I think this is limiting. Given we have this incredibly valuable asset trapped into MPS, we could think about better ways to get value out of it. So I think that MPS interoperability, so making tools communicate with MPS or the external world communicate to with MPS to produce more value, can be divided in 4 different aspects. The first one is bringing existing knowledge into MPS. Let's say that your client provide you a diagram in Visual Paradigm or some requirements in Excel files, you want to bring them into MPS to combine them with the knowledge you are going to build in MPS. Or you may want to generate stuff out of MPS. For example, you describe a great therapy in MPS, you then want to generate maybe a mobile application that the user can use to follow this therapy. Integrating of external tools in MPS means finding tools that can be used to enhance what MPS is capable of. For example, we have seen in the previous presentation that there was an integration of GraphViz to generate diagrams inside MPS. I will talk a little bit about this too. And finally, there is a 4th aspect that I think is more recent, and this is about making external tools communicate with MPS. For example, opening a web editor that talks with MPS and show you in a browser some of the information that is available in MPS. Okay, these are the 4 things I would like to discuss. Now, let's start with the first one, bringing existing knowledge into MPS. In general, you could do this in 2 very different scenarios. The first scenario is the one in which your organization has finally saw the light. They understood that MPS is where they want to build all existing knowledge. Unfortunately, the organization is not born today, so before they've built all sort of knowledge in other tools like Visual Paradigm, Excel, some other modeling tools, doesn't matter. We want to run one single time an importer, bring this knowledge into MPS and forget about what was existing before, throwing away existing files and editors. This is one case. Another case is the one in which we instead cannot forget about those external editors. And that could be the case because maybe for certain specific kind of knowledge, we have great external editors. Maybe our people really love to use Visual Paradigm to describe processes, and they want to keep using that for that specific piece of knowledge. Or another case is the case in which we are working with other organizations and other departments, and we cannot convince them to adopt MPS, so they're going to send us, I don't know, Excel files, and we have to deal with that. And every time we receive one, we have to use it inside MPS. So why you may want to bring all your knowledge into one place, and that place will be MPS? Well, the main reason I see is that because you want to verify that you have overall consistency. For example, if your clients provide you some requirements or test case as an Excel file, and you build a solution inside MPS, it's very convenient if you can import what your client have provided and verify that it is consistent with the solution you have defined. So this is one case. The other case, the case in which you want to abandon existing editors and replace them with editors you build in MPS, is because this editor that you build in MPS can, well, you are in control of them, so you can evolve them, you can add more and better consistency checks, and as your processes change, as you things you need to represent change, you can evolve these editors so that they fit perfectly your use case. So I think this is a good reason to bring stuff into MPS. Now, there are also cases in which you don't want just to read stuff that is created outside of MPS and just read it, but you want also to maybe change it a little bit while within MPS. You can do that, and you can do that with 2 different strategies. One is using one feature of MPS that I think not many are familiar with, that is the custom persistence. Probably you know that MPS store the models by default in these XML formats. You can also write plugins to MPS so that it becomes able to read and write models in another formats that you decide. For example, JSON, or for example, if you want to represent Python code, you may create custom persistence so that models are saved as Python files. This is one strategy. Another strategy that I've seen recently used in Modelis, this amazing project from Sasha Lisson, that we'll talk about it tomorrow, is the synchronization approach. Basically, you create your own models in MPS, and then you run a listener that observes any change you do in these models that initially is the same information as some external data source, and every time you do a change, you replicate the change in this external source. For example, let's say that you want to evolve some information that is stored in a database. You can initially create a copy, a model that has the same information as the database, and when you change something in MPS, you insert a record or modify a record accordingly in the database. So this is the synchronization approach, and I think it's very interesting. Now, another topic to consider is the kind of formats that you may want to import in MPX. Typically, I see these three cases. You are looking to some interchange format, XML, JSON, or Excel. You may not agree that Excel is an interchange format or it shouldn't be, but in practice, it's used in this way. Then you frequently have some kind of textual formats, and sometimes you have binary formats. Now, if you're dealing with these three formats, XML, JSON, or Excel, there are simply a lot of Java library that you can use in MPS using the base language, which is Java. So it's very easy to import these three formats. You should also consider that for XML and JSON, there are MPS language that could facilitate this task, because basically you can read these files using custom persistent and directly open them in MPX. So that's very easy. Another very common case is the case in which you need to parse some kind of textual format. Now, as Marcus said before, I work at Strumenta, we do language engineering, we do some project with MPS, we do some other project without MPS. In those other projects, we always use Antler. And there is no parsing problem that I was not able to solve, or we were not able to solve using Antler. So I'm not saying that Antler is always the best solution, but I'm saying that if you learn to parse stuff with Antler, well, basically there is no problem you cannot solve. No parsing problem you cannot solve with Antler. But I think you should be aware of these two repositories and these two projects. The first one is InMem Antler. Now, for people that are not familiar with Antler, Antler is a parser generator. It basically means that you define the grammar of your language, then you invoke the Antler tool to read the grammar and generate some source file in some target language. It supports many, but for example, Java. So it create a Java file. Then you need to compile that file. You need to add that class file obtained by compiling the file into your library, into your project. You need to instantiate the class. At this point, you can run your parser and run it with some input and obtaining a parse tree. This is a complicated build chain. You can instead use InMemAntler and basically do all of this in memory. So running the grammar, generate the Java source file in memory, compile it in memory, instantiate it immediately and use it. That's much easier. And another repository that you should be aware of is Grammars Before, which contains simply hundreds of grammars. So it's very possible that if you want to parse some common format, there is already a grammar that you can use. And so by combining these two projects with the capabilities of Antler, you can import relatively easily in MPS any kind of textual thing. In the case of binary formats, there is this old project of mine that is not extremely mature, but I've used it to import JVM bytecode and PNG files and basically extract the information I needed. It's a DSL to describe binary formats, and it's relatively easy to use, so maybe could be of interest to you. Okay, this was the first aspect of interoperability, so reading stuff and bringing into MPS. Then we have the opposite, so taking stuff out of MPS. And this is typically the case because, in a way, in MPS, you bring your knowledge or build it, and then you want to produce something valuable that can be used in the outside world. So one way of doing that is generating code that you can compile, and you have some executable that you can give to someone so that they can use it. Or similarly, you can generate some XML and JSON code, and then you have an interpreter running outside of MPS that execute this code. This is basically the same thing. You can also generate PDFs or diagrams so that human can watch, read them outside of MPS, or you can generate some sort of inputs for some software outside of MPS. For example, you can generate an AutoCAD file, or an Excel file, and someone else can use them outside MPS. Now, one thing to consider, one possible problem that some adopter of MPS see is the locking problem. Say, yeah, but what if I put all my valuable knowledge into MPS and one day I don't want to use MPS anymore, I'm locked into MPS? Well, this is not the case, because we are going to see that there are basically a million ways to generate stuff out of MPS. So to extract your valuable knowledge from MPS and continue your life without MPS if you choose to. Okay, that said, when we talk about generation, I focus on three different aspects. The first one is how do we trigger the generation? The second one is how do we deal with intermediate transformation? And the third one is how do we serialize the information? So basically, how we save it on file. Now, when we talk about triggering the generation, it seems to me that many users of MPS are familiar with only the first way of trigger the generation, so the standard way. You build your text generator, and basically every time you make your project, you build your module, this is triggered automatically, and some file is produced on disk. Okay, this is one way, but there are situations in which you may want to use other approaches. For example, in some projects we use the manual approach. So we create a new action that we add in some menu, or we add a button in the editor, and the user can click on it manually to trigger the generation. Why this is useful? This is useful when your generation is expensive. If your generation takes 3 seconds, it's okay to have it run it all the time. If it takes 3 minutes or 15 minutes, because maybe combine some external information or it's very complex, you don't want that to happen all the time because you mindlessly click on the make button. Also, if you're building complex generation system and you have side effects execute as part of your generation. For example, every time you generate something, you want that to be pushed to some external repository and a tag to be added. You don't want that to happen all the time that you just build the project. So you may want to have control, and this is why it makes sense to have the manual approach. And finally, sometimes it's useful to trigger the generation from MPS running headless, so from the command line, as a way to say, for example, as part of some continuous integration process. So this is another possibility to consider. Now, this third one, I think it's underutilized because it requires creating a build configuration. And this is one of the biggest pain points in MPS. Now, one thing that I want to discuss is the problem with transformation. And this is a problem I see every time someone that is not very familiar with language engineering try to write a transpiler, either in MPS or outside MPS. And the problem I see is this, that a lot of language engineers that are maybe not so expert tend to just think, okay, I have to transform this input to this output, I will just write a transformation. And if this input and output are very different, it will be a complex transformation. Suppose that you are trying to to translate Haskell into Java, if this is even possible. The languages are different, so the transformation will be complicated, and the result is that the resulting transformation will be unmaintainable. In those cases, it makes a lot of sense to create an intermediate model, one or more, so that you can translate your initial input into the intermediate model, and then your intermediate model into your final output. Now, this is even more important if your input is written in some DSL you created, because probably you're going to evolve this DSL. So the DSL will change over time, and if you have one big transformation you have to change all the time, it's going to be even more painful. While if you have an intermediate model and two simple transformation combined, what could happen is that many times, not always, you can be able to absorb a change in the DSL within the first transformation, obtaining an intermediate model that uses the same concept that you had before, and therefore you don't need to change the second step, the second transformation. And this is also valid for changes coming from the other direction. Suppose that initially you are generating some Angular application, later you decide that you want to generate some React application. So you may want to, in this case, hopefully you will just need to change the second transformation and maybe just a tiny bit of the first one. While if you have a single giant transformation that is a mess, well, it would be extremely painful. So in general, you want to split complex transformation using intermediate model, because it means having less complex transformation that are testable in isolation, and in many cases you are able to absorb changes on the input or the output. Now, there is also very good documentation about the standard model transformation, so in the generator cookbook, so you can read it. But there are also alternatives to using the standard model transformation. Now, these are alternatives that I think are very interesting, but I've not used extensively in projects, so I cannot speak intelligently about that, admitting that I can speak intelligently about other stuff. But you may want to look into the shadow models from Sasha Lisson, that has basically built half of the cool stuff out there, and Declare. These two frameworks permit to create incremental model transformation. So I think they deserve that you take a look at them. Now, once you have processed the information, you have a final model that is basically contain the exact representation that you want to save on disk. Well, you have the last step, that is saving that stuff on disk. Now, sometimes you want to save that stuff as XML, JSON, or Excel, and you can use the libraries, the common libraries that we have, like JSON, the one from Google, or tons of other libraries. If you need to generate binary formats, in my experience, this is much simpler than reading binary formats. So typically, I just use a byte array output stream and deal with that. And then there are cases in which you need to save textual stuff. In this case, you have two alternatives. If you are lucky, you want to target some language for which there is already a generator, because that language is already supported in MPS. That is the case for Java. Well, it's called base language, but it's Java. For C, the embedded project, there is JavaScript, the project from Marco Lombardo, if I'm right. There is R, that I think supported for Fabien Campagne, and there is XML. I'm not sure who wrote that one, and there are C#, C++ that may or not be open source, I'm not sure. But there is this growing amount of languages for which there is already a generator available. So if you transform your input into the models of these languages, you can then use the standard test generator that comes with these languages, and so you don't have to write your own. So consider that. If you are not lucky, you will need to write your own test generator, and there are different ways to do that. Now, I'm not saying this is something I would advise, but I personally like to write some code using the base language and string builder. I'm a simple guy. It works very well for me in many cases. In other case, you want to make a more sensible choice and using the standard text generator. You're probably familiar with that, but you should know that there is also the plain text gen, that is an alternative way to write text generator that is part of the MPS extension, and basically you can target that with model-to-model transformation. So it's a bit different from the standard text generator. I think it gives you a better idea of how the whole file looks like. I personally never wrap my head around that, but I'm a simple guy using the string builder, but you should look into that because for some problems it makes your life easier. Now, I want to point these articles, but I also want to point out to these blogs because one is from Kolya, the other one is from Sergey. They are both great resources in general for stuff related to MPS. I'm learning a lot reading those. And in particular, they have these resources on generation. By the way, at the end, I will give you a link where you can download the slides. So if you are trying to type in all the URL so far, well, you didn't need to. Maybe I should have said that at the beginning. Now, one particular kind of stuff that you want to generate is documentation. Now, I've copied a piece of an article that Marcus wrote about writing a medical application using MPS. Among the other things done in that project, there was a lot of generating of documentation. In general, generating documentation is a great way to ensure that your documentation is aligned with your code. So that is a point to consider. And you can generate all sorts of stuff. You can generate a testable file, but you can also generate tables summarizing results. For example, the result of the running test, the number of tests, the number of failure. You can generate reports showing the test coverage. You can generate reports showing the number of algorithms, so you could have complexity for metrics and show diagrams of how complexity evolve over time. We have generated all that stuff. And this may be something, this documentation, that you need to generate to give it to people that have not access to MPS, maybe because they're external partners, they don't want to use MPS and read the information from MPS, or because you need to provide this information from a regulatory agency like the FDA. So these are reasons to generate documentation. When you generate documentation, there are at least three kinds of tools you may want to use. The first one is the embedded documentation language. The second one is PlantUML, with or without the Plant MPS plugin. And the third one is Graphics. Now, the embedded doc or documentation language, I never understood how it's called, is a language that would deserve its own presentation, but basically you can use it to write text, to add links to some images. You can embed piece of models that will be rendered. And in the end, you can generate PDFs out of it. So it's a great way to write documents directly inside MPS, and very rich documents. So take a look at that. Now, there are graphics and PlantUML that you can use it either to generate documentation outside, or you can use it directly inside MPS. And so we are jumping to the topic integrating tools inside MPS. Tom has already discussed this topic, so I'll not spend much time on it, but basically I created this example in 20 minutes, a very simple process language, and then I want to show a diagram that is generated based on the content of the process, and I can click on the different elements. This is relatively easy to do that in MPS. And as Marcus also said, typically users start a project asking you to create some graphical language. In practice, in the end, it's very practical to have a textual language that is more productive, maybe with tables, and then generate some read-only visualization. And Tom showed how you can also listen to the original model and update the picture. So this is a nice idea, and I will steal that. This is another example built using Plant MPS. So a plugin that I think is part of MPS extension, and it took me literally 5 minutes. So I want to communicate that these integrations are relatively easy because you don't have to rewrite Plant UML. There is already the integration in the project Plant MPS, so they are ready to use, and you create a nice visualization in MPS and then enrich what you can do in MPS. Now, there is this other project that I read about, is Fasten, Formal Specification Environment. I think Daniel Razziu has played a big role on it. So Daniel Razziu is, of course, another key member of our community, and I'm also personally very grateful to him because he and people at Itemis has really helped me when I was learning MPS for the first time in 2012, I think. And among other amazing things that he has built this project, and I think the interesting thing here is that they integrate with this tool, a model checker tool, to perform complex analysis on tools. And this is, I think, a very nice example of how you can use tool to complement the capabilities of MPS and build something that overall provide much more value. So I think it's a nice way, and it's a nice idea to take a look at this project. Now, following a suggestion from Marcus, I just added this slide about the integration with build servers. Of course, one external tools that need to use the capabilities of MPS is a build server. Now, the problem with building integration with build servers is that you need to build to write build module, which is complex. There are great videos from Colia on this topic, so I suggest to look for them because they're really helpful to dive into the complexity of this topic. But then you should be aware of this project. The first one is a project that has been around for a long time, built by Itemis, big surprise, and is called MPS Gradle Plugins. It contains a variety of tasks that you can use to basically integrate the build module. The build module generates a task. You typically want to call it from something more modern, like Gradle, and so this project can help you. There is another project from Sergey that is also called MPS Gradle Plugin. I admit that this seems a bit confusing to me, but is used instead to package and publish MPS languages as Maven packages. So that's also very useful. Same name, but does something different. And then, again, from the Embedder project, we have this project Embedder Build Docker. Basically, it gives you a Docker image that you can use in TeamCity to run MPS headless and run your builds inside TeamCity, another product from JetBrains. Finally, we have the fourth kind of interoperability. That is, I would say, more recent, and these are external tools that talk with MPS to do something valuable. So they try to take advantage of the great feature of MPS to do something outside of MPS. One project is this project we have created at Strumenta that is called MPS Server. the basic idea is to make all the MPS API available from outside MPS, so that you can have MPS server running, for example, headless on a server. You can call it through HTTP or WebSockets and ask it to read the models, to change a model, get information on concept or languages, calculate the type of something, trigger an intention, all sort of stuff. Basically, sort of remote access to the MPS API. And this is open source. This is just a subset of the route you can call. For example, you can call /languages, and guess what? It gives you the list of languages that are available in the MPS on which MPS server has been installed, because MPS server is basically a plugin for MPS. Now, MPS server is something that you may want to use if you want to reuse the runtime capabilities of MPS. There are situations in which you just want to reuse the models that you've created in MPS outside of MPS. So MPS shut down, you just want to read these models. There are a couple of projects you can use. The first one is called MPS Analyzer from Mente Borsma. And this project can be used to read models outside of MPS. I think the project is written in Kotlin. You can perform simple fixes for some typical problems that you have with MPS models, and you can access them from Kotlin code. So that is an interesting possibility. At Strumenta, we have built something similar because we have slightly different needs. And there is this other open source project called MPS Interop that can read MPS models, but can also read MPS model in binary format. When you create models, unless you create your own custom persistence, models are saved in this proprietary XML format created by JetBrains, right? However, they shipped with MPS some standard libraries that are stored in another format, the binary format, which is more efficient. The problem is that when you create a language that depends on this standard library, for example, because you're using iname concept, you may need to read those library in binary formats. And this is why we created MPS Interop. For example, we have this use case in which we have created a simple class, in a Java class inside MPS, and we want to generate a corresponding TypeScript class. And we didn't want to have the generation run inside MPS. We want to have this generation running from TypeScript because we had libraries in TypeScript to generate TypeScript code. Was easier. So we wanted this. Now, the problem is, if you try to read directly the MPS file that stores this model, and you look at the piece that correspond to this field declaration, you can notice, first of all, that is a line 21,000. So you can imagine how complex are those files. And basically, you cannot understand anything because it's all use all sort of indexes, use some compression format. It's complex to use it. So MPS Interop will read that file, will read all the files that are dependent, that are referring to that, find the definition of concept, and give you a JSON where you can understand the information. And so, for example, we can understand that this field declaration is of string type, is visible, and the name is container name. So from TypeScript, we read this exported JSON, and we do our thing. This is something also we generated using this approach. Now, another way to integrate with MPS from outside is to use WebEdit I will not talk much about this today because I have another presentation 2 days from now about WebEdit. But WebEdit is basically a TypeScript framework that you can use to create editors that talk with MPS server, and so get the information you have in MPS. And the basic idea is that when you open the editor, it calls MPS server and get the information on the model and use it to draw something on the screen. And when you do something like typing or changing a reference, it calls back MPS server and tell MPS server to change the model. So conceptually, it's not very difficult. Now, there is this other amazing project. We are going to have a presentation about this. Sasha Lisson is going to give this presentation. This is built from a previous project they created at Themis, put a lot of work on this, and this is simply amazing, open source, available right now. I've also contributed recently at this project, and I still understand just a tiny bit of all the amazing feature that ModelX has. The main feature I understand is this. It permits basically to save your models on a server or a cluster or server and fancy configuration with Kubernetes things that I don't understand. And you can basically access this model from your MPS, and if you have 2, 3, 4 people edit the same models, they will see the change of each other. So that's basically magic inside a model server. There is also one other part that I never use, but it's also amazing, that basically permits to see, if I understand correctly, the same editor you see in MPS inside the browser. And it has almost all the features you have in MPS, but in the browser. So it looks amazing. So attend the presentation of tomorrow. Now, a quick recap. We've seen that there are many different ways to complement MPS. We've seen that we can import stuff. We can have one-time import or continuous import. We can import stuff in binary format, textual format, common formats. We can generate stuff. We can trigger the generation in different ways. We can use different transformation. We have different kinds to perform text generation. We have different ways to generate documentation. We can integrate tools like model checkers or graphics or PlantUML to have graphical representation. These are some examples, but you can apply the same mechanisms to integrate other valuable stuff into MPS. And finally, we have this more recent series of tools to take advantage of the capabilities of MPS from outside MPS and enrich the ecosystem. So we have seen that basically there are many different ways to complement MPS to make an ecosystem around the creation and usage of knowledge. So we can integrate existing tools and to create more complex processes and have a richer ecosystem. We can use the generation of documentation, for example, to facilitate discussion, both for internal communication and for training of new personnel. We can improve R&D by importing existing knowledge or by integrating like tools like model checkers, for example. So you can create a richer ecosystem and improve the way you build and use knowledge. And basically, you can leverage the existing knowledge you have outside. You can leverage the existing tools that you have outside MPS and complement what you have in MPS. And vice versa, you can leverage all the value you put in MPS by reusing its capabilities from other stuff that run outside MPS. And incidentally, this also reduces the lock-in fear because it shows you that MPS can be one component in a much larger ecosystem, a vital and core component, but one component in something larger. Some consideration, I think that on many different aspects, we have seen that there is amazing progress. There are great ways to generate stuff. But I think that integration with external tools can grow a little bit, and I think that a project like ModelX and MPS Server can really help us. going in that direction. Another thing that I want to stress is this. Of course, as a community, for many years, the community has been basically Itemis and people like Daniel Razio at Fortis and then at Siemens that have built this initial critical mass. But it was very nice to study what exists to create this presentation and see that there are contributions from a lot of people. I wrote some of the name of the people that wrote article, create tools, create languages, and wrote them on the slides, and I'm sorry for the one that I forgot. But it shows you that we have a community and this is growing, and hopefully also the participation to this event will confirm that this community is growing. So please be an active part of this community and contribute. Finally, there are some resources that you may want to consider. MPS Rocks from Colia, amazing list of interesting stuff created with MPS. There is the Slack channel of MPS, and there is the Strumenta community we have started that is we talk about in general language engineering, but many of the participants are very interested in MPS, so we often discuss also MPS stuff. And well, that's it. You can find the slide with all the links to the amazing stuff people have created. So thank you.
All right. Thank you very much, Federico. As I mentioned before, I really like this talk because it emphasizes how MPS can play well with other tools, and because it also highlights how different people in the community have contributed various utilities and things. So that's a very, very nice message. I have a couple of questions from the chat. One is from Julian. I'm glad Federico referred to the custom persistence for data input. I want to know how to do this. So we only have 13 minutes left, so probably not time for a tutorial, but maybe you have a link or something that you can point people to, a documentation of custom persistence or something?
I think there was a link, and again, you can access the slides, so you will find it. There is a cookbook as part of the documentation. Now it's okay, it's stuck, but anyway, there is somewhere eventually the slide will move. But in general, yeah, here it is.
Right.
In general, it's not trivial. So if depends on how familiar you are with MPS, but basically it means creating reactive to things you can expect, like writing a piece of code that is called when you try to save your model and when you try to load your model. So you will need to create programmatically nodes using the S-Model API. And I've used it for some prototypes, and I remember it was definitely not trivial, and there are not many people using it. So I think this part of the documentation is fairly good, but it's true that it's difficult to find examples, so that could be challenging. Luckily, we have the Slack channel from the MPS community, so probably you will need to ask for help there.
And Bernd also just pasted in the YouTube chat that there is XML persistence sample in the MPS samples, which contains working code. So that's also something to look at maybe.
Yes, and just to clarify about that example, MPS by default is very complex XML format. But as an example, they've also created another persistent that also uses MPS XML, and so that could be confusing, but produce an XML that is very simple and linear and readable.
Yeah. Okay. So what do we have? More questions. Jack is asking, why is generating documentation not a lot used? It's a rather philosophical question, it sounds to me.
Well, I think I should ask it to someone else because I use it, but maybe sometimes I think it's it's not obvious to think about the things you can do with MPS. So today I wanted to talk to all the other things that you can do besides creating languages and using them, right? And sometimes, if you have not seen those being used in other project, it doesn't come to mind that you could do something like this. And the embedder doc language, I hope it's the right name, it proves that there is some need for that, and maybe we can look for usages of that one to see project that use documentation.
I think there are two different cases, right? One is where you have actually manually authored documentation. You can do that outside of MPS or inside of MPS. If you did inside MPS with the doc language, it is easier to embed nodes and refer to stuff and kind of build almost like literate programming style living documents or executable documents. That's one thing. But the other kind of documentation generation is where you do not explicitly author the documentation, but where you generate from the model some more readable or printable or PDFable representation of the model, visualizations, diagrams, things like that. And these are usually done by people who are forced to do it, like in the healthcare example or in the space domain where Andreas Wortmann of OHB basically generated all the sequence and class diagrams that he's forced to submit to ESA when they are trying to get some of their satellite software certificated. Nobody's probably ever going to look at them, but they count pages, right? So you have to generate all this crap. And so that's the other kind. And that is something that people usually only do if they're forced to.
Yeah, and probably, and this is part of the larger problem that we often discuss, this is maybe the boring bit that project that I mean, is not discussed outside the usage of a specific client, so people don't know about that. So that's a point. Another things that I was thinking right now is that those projects where we were generating PDFs, I was using a PDF library to generate the PDF. I was realizing maybe that was stupid. I could generate the embedder doc language model with the embedder doc and then generate it from there.
Maybe.
Because it was a pain to generate PDFs with this library. So I wish I considered that before.
So if even you don't know that something exists in the platform, man. So another comment by Paul, not a question here, but just something he wants to say. Please pass on my thanks. Federico's blog got me through my software construction class in my master's degree. So that's nice.
I'm happy to read about that, or to hear about that.
Yeah, and then Paul is also asking a question. Is the process DSL, I guess that was your 20-minute example, right? Is that on GitHub?
Is on GitHub. Maybe I didn't make it public yet, but it was something very simple. I can definitely make it public. It was simple, but maybe if it's interesting, why not?
Okay. And we have to correct the reputation of ESA. Mainte just mentioned that his wife works there, and she confirmed she does read the UML diagrams when she finds them. But it has to be UML diagrams and not any other diagrams. I added that. All right. So if there are no more questions, then thanks again, Federico. Obviously, as usual, very interesting. No more questions. All right. So this concludes more or less day 2 of the MPS Talks 21. Tomorrow is Web Day, right? We have 2 presentations about integrating MPS in various forms into the browser and the cloud. The first one, as Federico already mentioned, is Sascha Lison's presentation about Modelix. And the second one is a presentation by more or less the whole MPS team. It's like 4 people, Simon, Katerina, Daniel, and Elena, about the biological knowledge base. It's a project that JetBrains has been running for a while. which on the one hand side tries to capture various forms of biological knowledge as it is created in the lab, as far as I understand, and it relies on web MPS, so it runs all of these languages in the browser. So it's kind of two different takes on how to get MPS into the browser and into the cloud. So this should be very exciting and probably points a path to the future for the MPS ecosystem. All right, so that's it. See you tomorrow, hopefully. Enjoy the rest of the day. Ciao.